In Chapter 2, we start talking about basically our chemistry unit. So we need to have some basic understanding of terms in order to be able to have a good basis for understanding all that goes on in chemistry. So that's where we're really starting, is just with some terminology. So we start with the idea of what is matter. I'm sure you probably already kind of know what is matter. It's easy to name a lot of examples of matter because almost everything has matter, because almost everything has mass and takes up space. So that means that matter is anything that has mass and volume. It's pretty simple then to say anything I can touch or feel is matter. Some of the things that we often forget are matter is something like the air, because we forget that we have something there that does have mass. It does have volume. Volume is easier to understand about air because if we blow up a balloon, we see the volume increasing. The mass is a little trickier because the mass is so incredibly small because air is not very dense. But if you had a very precise balance, you could put an empty balloon on the balance and find its mass, and then blow up the balloon, put it back on the balance, and find out it does in fact increase in its mass, meaning that the air inside of it does in fact have mass. So even though we forget, air is matter, and so is everything else that we can touch or feel. When we talk about matter, matter really gets divided into two main categories. Either it's a mixture or it is a pure substance. We're going to start with the pure substance, like the elements. When you look at the periodic table, you're looking at a list of the elements. The periodic table has somewhere around 118, I believe, right now, elements. That changes frequently. I guess frequently is a relative term, but it changes when a new discovery is made. Typically now, new discoveries are those that are very, very large elements because scientists are discovering new elements by colliding atoms of other elements together, and if they stick and they hold together long enough, they can actually call it a new element. But when we talk about them in general, what we're saying is that an element is a substance that cannot be separated or broken down into simpler substances by chemical means. So that means that it's at its most basic. We can't divide it down any further and still have an element. Yes, there are smaller parts than the atom in an element. However, if we broke it down further, we wouldn't still have all of the chemical properties and physical properties of that element. So at its most basic, an element is made up of atoms. Atoms are considered to be the smallest unit of an element that maintains all of the properties of that element. So it has the right combination of protons and neutrons and electrons. We'll find out later that it's specifically the protons that are important. But so when we have the right combination of small parts, we have an atom, and the number of protons ultimately determines which element we are talking about. When you look at the periodic table, you'll see that oftentimes the names are on the periodic table. Sometimes the names are left off, but the symbols are always there. The symbols are letters or groups of letters used as sort of a shorthand to represent the different elements. It's not practical when you write out a compound, for example, to write out the full name of every element that's involved. So instead, we use a combination of the symbols. Symbols are always going to start with a capital letter. If there is a second or a third letter, those will always be lowercase. When atoms combine, they can make up a molecule. That is a group of atoms, but they are held together by chemical bonds. Those molecules then can exist by themselves and have all of the properties of another substance that we call a compound. So if we have groups of elements that have bonded together, what we have formed is called a compound. So you can see here the definition of a compound is a substance made up of atoms of two or more different elements joined by chemical bonds. It's really important that we notice the word chemical because we don't have a new compound if we put elements together that do not react with each other chemically. If they just mix together, what we have is a mixture. So in order for it to be considered a compound, they have to react chemically. That is a necessary step. What's interesting about compounds is that compounds are always very different than the elements that make them up. They have unique properties. A great example of this is sodium chloride. Sodium is a metal. In fact, it is kind of a grayish silver metal. When you cut it, it's pretty soft. It's interesting because when you put it in water, it spits and spatters, and if you put a big chunk in water, it can even blow up. Then we combine that with chlorine. Chlorine is a halogen. It is a fairly stable gas. It is kind of yellowish and green. It's quite dense, so it usually sort of sinks to the ground. It kind of hovers along the ground. It's extremely dangerous. If you breathe in even small amounts of chlorine, it can do quite a bit of damage to your lungs. People can die from breathing in chlorine gas. But when we put this explosive metal together with this dangerous yellow-green gas, they combine and they form a new compound called sodium chloride. Sodium chloride is a white crystal that we sprinkle on our French fries, and it's quite tasty. Of course, it's table salt. So compounds' properties are very different than the properties of the elements that are in them. We use a chemical formula to represent compounds. Instead of writing out all of the individual parts, we instead use the symbols and some numbers to show what is in a compound. So for example, this is indigo. Indigo is made up of 4 different elements. You can see 4 capital letters, C, H, N, O. And then after them are numbers. And you'll notice those numbers also are subscripts. So C16 means that there are 16 carbons. H10 means 10 hydrogen. 2N means 2 nitrogen. And O2 means 2 oxygen. So always, if there is more than one element, then there is a number present. If we ever run across something where there's only a single atom of that element in the molecule, then we just use the letter and we don't use the number 1. So you will never see a 1 as a subscript. The fact that the letter is there, that in itself tells us that there's one of that element. It's only when there are multiple atoms of the element that there is a number. So in this case, with indigo, all of them are in multiples. You can see the 16, 10, 2, and 2. If we don't have an element or a compound, which are the only 2 pure substances, and they are pure because they are made up of all the same little tiny particles. There's nothing different mixed into them, so they're considered pure substances. We define that as a sample of matter, either a single element or a single compound that has definite chemical and physical properties. So what's really cool about a pure substance is that it doesn't really matter if we have a little of it or a lot of it. It has the same properties, the same density, the same melting point, and so on. It also doesn't matter where the sample comes from. So if we have a sample of, uranium that is found in the Middle East, it would have exactly the same chemical and physical properties as another sample of uranium that is found in North America. So every single sample will have the same chemical and physical properties. That's what makes it a pure substance. That is not true when we talk about a mixture. When a mixture is made, we have a combination of two or more substances that do not chemically bond together. So each of the parts maintains its own unique properties.